out here looking at a PCV system on a 2000 Ford Ranger. We're looking at the components here. We have our oil separator, number 5, our vent hose, number 4, number 3 is the actual PCV valve for this truck. And we will now move into testing this system.
On the clean air side of this PCV system on this Ford Ranger, we're doing a dollar bill test, except with a receipt, obviously. And for this test, we're just making sure that there's vacuum being pulled into the valve cover here. So whenever we pull this piece of paper off, you can see that there's vacuum that's being created. And then it draws that piece of paper back onto the valve there. And that's how you perform a dollar bill test on a PCV system.
Here we're looking at the PID data values as we take off the clean air side to the PCV system, introducing an unmetered air leak. We see here that our O2S11 went from 0.395 to 0.040. This shows that the motors went lean due to the unmetered air going past the MAF sensor. Short-term fuel trim rose from 2.3 to high teens, and the RPM decreased rapidly when we introduced the leak before it was able to catch up. PCV testing, it came to our attention that the IAC was not operating to full standards. We had a very high RPM at 944 commanded by the PCM, and the IAC was acting kind of sluggish in its action, so we took it off to inspect it. Here we are ohm testing it, and we had about 24, which is normal. And then we took a look inside to make sure it was not clogged, and it appears clean. So our next step here is testing it for its movement. See that it does move, although we're not sure if this is the full range. Next, we tapped into the IAC control circuit to manipulate the motor in order to have the IAC want to move, while also watching the PIDs to see what the commanded is and comparing it to what it is showing, also compared to the engine performance. How we were able to read the IAC circuit on the Pico. This blue channel A shows us our power feed, and the red channel B is our driver circuit, a ground driven circuit. And we can tell here that one cycle, as indicated with these large bars of one up and one down, the down shows us our grounding of the circuit, which should be our on time. So we can see here we have about a 50% on time here, and that should correlate to about 50% open. You can see after manipulation the command now changed to around a little over 35%. And next frame we can see that the actual command was 39%. So we know that our circuit is pretty good at communicating what command it would like to see out of the IAC. Here we were led into looking into why the desired idle is so high at 944. We noticed that the ECT temp was kind of low. We ranged from about 176 into the high 170s in this test alone, and so we're not having much motion, and we kind of have an erratic pattern with it. So we're thinking that this may be a cause, but we still need to confirm it by making sure our cooling system has proper amount of flow and that the sensors can read correctly. If that's not the issue, it'll have to be looked into further. Moving on, we are taking a look at this 2002 Toyota RAV4, the 2-liter 4-cylinder. Analyzing the PCV system, here on the left we see our fresh air tube, and on the right we see out of the valve cover through the PCV valve and into the intake. Here's a all-data image of the PCV valve on the back of the valve cover, and here's the valve from the vehicle. Appears a little grimy, but we shook test it and it rattles, we can also blow through it.
The PCV system. Over here we have the clean air side. Goes through, out the PCV valve, into the intake. Right now we're gonna dollar bill test it. You can see that it's pulling. So we know that it's working.
Moving back into the Ford Ranger, we're taking a look at the EGR system now. This is a differential pressure feedback system, DPFE. On the left here we can see the components of the system, and on the right we can see our diagram of the system.
So for this vehicle, which is a 2000 Ford Ranger, we have three different components I'd like to show you for our EGR system. The first one being our vacuum regulator down here at the bottom where my middle finger's pointing. This has a filter on the top too that's removable. As you can see, I can turn this, and if you were to replace it, you could take this cap off and there's a piece of foam in there. Back here is a differential pressure regulator. This component is located in the rear on the passenger side. And then you come up here and we have our EGR valve right here sitting on top. Okay, so pulled up on this scan tool, we have two PIDs that we're going to be showing you today. Our DPFE PID, which is specific to Ford motors, and our EGR-VR PID, which is our EGR vacuum regulator PID. So that would be monitoring the component down here in our EGR system, which is our vacuum regulator, which we showed you earlier. And the DPFE monitor up here, this PID, shows us this component down here, which is our differential pressure regulator.
So now you can see here the DPFE voltage is around 1 volt.
We're going to go down here and take off the line on the smaller of the hoses, and we can see that it drops very slightly. It's definitely reading, and we're gonna put this vacuum on it. And we'll watch it as it changes. So that's about 7.5 inches of mercury, and we're almost at 5 volts here. We're at 4.3. Bring it up a little more, and we can see the more vacuum it has, the higher the DPFE voltage is. You get 10 pounds, and we see a schematic of the DPFE sensor circuit that we were just getting our PID values from. As you can assume, it's very similar to a potentiometer with that range of voltages.
For our EGR vacuum regulator hooked up to our output driver circuit, we have a jumper lead, and we're going to jump this to ground. And what this is going to do is it's going to open our EGR valve up here all the way, and it's going to stall our engine out. So here I'll show that happening now.
Look at the schematic for the EVR. So you can see we tapped into the pink and brown wire on the bottom because that is the driver wire.
Now we're bypassing the EGR vacuum regulator valve. We're going straight and applying vacuum to the EGR valve here. Let's see how it is. See, the idling motor does not like being exposed to EGR gas.
Moving on to the Suzuki Grand Vitara, the EGR valve is on the back of the intake, right up against the firewall, so it makes it pretty hard to access. This is a 6-wire stepper motor style EGR valve. On the left is the Suzuki wiring diagram for this motor, and on the right is a 4-wire stepper motor. This is what we're going to use to look into the process of this type of valve system. Looking here at this 2-coil IAC motor probed in to one of the driver's sides of a single coil, we're getting 4.93 volts, showing that we're about half voltage on, half off. Now we're probed into both driver's sides of the coils, and we see here that we have an overlapping square wave of the commanded on and off times of these coils, allowing this motor to step when commanded by this trigger. And that is all for this video.